everyone. We continue with what we left in the previous video. The topics that we already covered are pointers to derived objects, virtual functions, and dynamic binding. In this video, we learn about pure virtual functions, virtual distractor, and this pointer. First, we see about pure virtual functions. The virtual function inside the base class is rarely used for performing any task. Such functions are called do-nothing function. If you remember in the previous video when we did the last program for dynamic binding, we used a function, overriding function called void display of. We had one base class and two derived class, hierarchical inheritance we followed, in which the two derived class we used void display of, and it has been defined in a meaningful manner. But we use the same void display of in a main function, that means in the base class, but we haven't defined anything properly. It doesn't give any meaning. Since we have already introduced overriding in the derived class, it is mandatory that you have to introduce the same function in a base class. You have to define it. It's not only declaring, you have to define it. So what I did is I just typed it's a base display. That's what I just gave in the display function. So those kind of functions, we call it as a do nothing function, and we have a separate syntax to use such kind of virtual functions inside the base class, not in derived class, only in the base class. So this is the syntax we have to use. I have to make the base classes function as virtual. So virtual return type as void display of, and mention it is equal to 0. So if you mention anything equal to 0 using a virtual keyword, that means it understands it's a do nothing function. So it will automatically declare this function has been declared and as well as defined. So you can take the same example and try this concept. It will work perfectly. It won't pass any error. You don't need to unnecessarily give something in the definition as this is the best, this is the base function, and this is a nothing function. You don't need to define anything. Just say virtual void display of equal to 0. So the program will automatically understand it's a do nothing function, and it will take it for granted. The next is this pointer. It's a quite interesting pointer that we are going to learn here. Like constructor and distractor, even if you are not explicitly defining this pointer in a program, the program will automatically consider or take all the variables or take all uh, the variables that you use in the main function or in the member function with the support of this pointer. If you want to take a variable from a class to main function or member function to class or anything that you want to shift over, this pointer is going to help you to take all the variables then and there, move here and there. Let me explain that. So C++ uses a unique keyword called this to represent an object that invokes a member function. So if you want to invoke any object or even a variable, here I have mentioned object, even a variable can be invoked using this pointer. This is a pointer that points to the object for which this function was called. I given an example here, just a small example. I'm saying A as a class name and I have variable as integer A. This can be called in two ways. One, the private variable A can be used directly inside a member function like A equal to 12. Directly I can say A equal to 12, or I can use something like this. This and arrow A equal to 12. These two are acceptable. In either way you can give it. Even if you're giving us A equal to 12, implicitly this arrow will be automatically assigned for this variable A equal to 12. That's the beauty. So whatever that is being implicitly defined, we are going to look into a program how to explicitly use that inside a program. And this pointer can be used explicitly for certain circumstance. We are going to take that example in this circumstance. In certain circumstance, how we can able to define the variable and how to introduce this pointer at the particular situation. And we have one more concept called virtual distractor. We don't have any particular definition for it. We see a program for that. So totally we are going to look around three simple programs. The topics might be quite complex, but I'm going to explain it with a very simple program for pure virtual function, this pointer, and virtual distractor. Let's get into code blocks. First, we see a program for pure virtual function. I have a class name called book, and inside public access specifier, I'm going to have only one function, and that is going to be a pure virtual function. So let me have a function called same void display. You can have any name. I'm just giving as void display of, and this function is going to be a virtual and do nothing function. So if it is do nothing function, say equal to 0. This alone I'm going to have in my base class. So let me have two derived class. So class, let me say derived 1, so d1, and I'm going to inherit in a public manner book. Let me have the same function void display of. I'm going to print some book name, some text which I'm giving here. Okay, so likewise let me have another derived class inheriting in the same manner. Use the same function. Okay, so we have same function name. You can see void display of in all the three classes, one base and two derived class. Since I have used the same function name and with same parameter, we call it as a function overriding. If you're using function overriding in derived class, it is mandatory that you have to define, you have to use, and as well as you have to define it. So we have a shortcut. Instead of defining, I can say equal to 0. So that means this is your pure virtual function keyword. So you won't be having any problem. Automatically this function is considered that it is declared and defined. Now in the main function, since we have used virtual, you have to introduce a pointer for the base class. So book is a base class name, and let me say pointer p, and let me give an array. Since I have two derived class, I explained about this using array in pointer in the previous video. Hope you're clear. I'm using the same here. My first, so I have to create an object for these two derived class. For d1, let me say derived 1 as a base, I'm sorry, object name, and d2 derived 2 as object name. So let me assign the pointer, let me assign the object to the respective pointer. Let me call the first one, first array of pointer 0, and don't forget to use this arrow symbol. So derived 1 of, so I need to pass this. I'm sorry, we are not calling a function, we're just assigning it. I'm sorry, it's equal to, and use the ampersand symbol. So now the address of first derived class object is passed to p of 0, pointer of 0. So likewise pointer of 1 is going to be assigned with my second derived class object. Now you can call the function using the first pointer. So at that time use this arrow and call display of. Likewise my second array pointer, and using that I'm calling display of. and 0. So let's check the output. Got it. This is a programming book, this is a theory book. So successfully I have called the two derived classes function using the pointer assigned for my base class. And please understand this program is mainly for how to use this pure virtual function. So if you are not using pure virtual function, in case if you are not using it, and make sure you're defining something like this. You don't have anything, but you can define like this. An alternate method is equal to 0 and virtual. Okay, so this is about your pure virtual function. So next we see about this pointer. Let's see one simple program, how to use this pointer in a particular program. So I've created a class name called test. Let me have a situation like I'm having a variable like a, and inside public access specifier let me have a function called set of, and it's going to have one parameter and it's also going to have the same variable a. Now I'm going to pass the value from this a to this a. So how will you write this? Write a equal to a. How the program is going to understand this? That's the next question. Let's check that. So let me print this. It says cout, and if I say a equal to, the compiler will get confused which a I'm calling here. Am I calling this parameter a or the declared a? And if you run the output, what's going to be the answer we get? So let me give the value here. Let me create the object first for test. Let me say t is the object, and let me give the value a equal to 100. And now using the object I call set of, I call that a here. Now again I'm going to call the function print of. Quite simple one. We have variable a and then we have a normal function. So inside the parameter again I'm giving integer the same variable a. I'm assigning this value into this a. So I say a equal to a. Now I'm printing a. Now the compiler will get confused. I'm calling this a or this a. Even if it is going to call this a, what is going to be the output when you have a situation like this? You have same variable at both the sides. And here I'm giving the value for a 100 and I'm calling the function set underscore a. So 100 is going to be passed here, and next I'm going to print a here. So we know very clearly a is going to have 100, so 100 is going to be passed here. So a has to display a value as 100, isn't it? But when you have same variables at both the side, just check what happens. I give the value as 100. What do you get here? A equal to some value 7208832. I got a garbage value. I didn't get the answer 100. This is the reason when you have same variable at both the sides while you're trying to assign here. So at this circumstance, you have to mention explicitly this and this arrow symbol and say a equal to a. So what I'm going to print here is this a and not this one. I'm just making a difference here. So make sure a variable here, either this side or this side, or it's up to you. Usually we go for the left side. So here I say this arrow a, this is what I'm trying to assign. This is what I'm trying to print here. So mention very clear this arrow a equal to a. So now the compiler will understand very clearly. So what variable is assigning to what variable, and now the output is going to be quite clear. I got the answer a equal to 100. So this is one situation where we may need to use this kind of pointer explicitly in a program to give a difference. So when you create any big programs, when you have such kind of complexion, don't try to change the variable. Oh my god, I'm using a here and I'm using a here. Oh no, I just change it to y here. Just understand, when you try to change a variable here, the same variable or same function might be used in some other classes also. So you may have to keep changing in all the classes where the same function has been called upon. So that might lead to a big problem, or you may have to do a lot of work in changing the variables related to this variable. So stop doing all this. Just give a difference between this same kind of variable using this pointer. That's going to give a clear picture to the compiler how the answer has to be printed. Okay. This is about this pointer, and next we have a last one, virtual distractor. Let's see one program for that. We already have a program for distractor. If you remember, we learned constructor and distractor in inheritance. So I'm going to take the same program and I'm going to explain how virtual distractor works in that. And one of the important property in virtual distractor is um, we can't make a constructor as virtual, but we can make a distractor as virtual. So that's one key point where you have to remember. Let me take that program. Yes, here is the program. Hope you remember this. We have two classes, one is base, another one is derived. Under the base we have one constructor, one distractor. Under the derived we have again one constructor and one distractor. So I am creating an object for the derived class. So we know the drill, we know what is going to be the output. First the constructor will be called. So we know the order. First base class constructor will be called and derived class constructor will be called. So once it reaches the end of the scope, the derived class distractor will be called, and then it goes for the base class distractor. So just check the output. I'm sorry, I didn't save this properly. Check here, base class constructor called first, and then derived class constructor, and then derived class distractor, and then base class distractor. Now we had a property mentioning that we can make a derived class as derived function as virtual. That means not the constructor, but the distractor can be made as virtual, and not in the derived. I'm sorry, that's in the base. So in the base class you have two types. One is constructor, another one is distractor. You can't make a base constructor as virtual, that's not possible, but you can make a derived distractor as base distractor as virtual. But at what circumstance? At it may come at any circumstance during your requirements. You may have to create a distractor, you may have to explicitly use the distractor, but sometimes that might pass an error if you do so. There are few steps to be followed if you're making a distractor as virtual. First important thing is we have to do upcasting. and the term is something new for you, upcasting. Uh, but this is not the right program for you to explain what this upcasting is all about. Just let me tell you what upcasting is. Here, the base class, we have to create a pointer. So let me create star p as a pointer. I'm not going to stop here. I'm going to upcast it. So I say equal to new. So this new is a keyword we use for dynamic memory allocation. So where I'm going to allocate here is for derived class. This statement is mainly called upcasting. The concept of upcasting is whatever properties that is present in the derived class will act like a base class. And this statement will ensure that, I repeat it again, whatever properties that is present in the derived class, derived object or derived pointer will act like a base properties. That's how we go for upcasting. But we have a separate program. I'll send as a PDF to explain more about what is upcasting and some other programs also. Upcasting is not a very important topic, but you should know how to cast base to derived or derived to base using the pointers. So what happens in this line is the base created a pointer, and then I am allocating a memory. That means dynamic memory allocation is done for the derived class. So automatically this is going to kickstart my base classes function using the derived class. So once this line is executed, it jumps to my derived class. It looks for whether it is inheriting from anything from the base class. Of course it is inherited, so it goes to the base and it start executing all these. So first it goes for the base class constructor, and next it goes for the derived class constructor. And what about this destructor, how it is going to be called for this particular line? Okay, so if I want to call the destructor, I have to exclusively use delete this pointer. That means whatever pointer that I created, it should be deleted. So once it comes to this line, usually I say that once it goes out of the scope, the destructor will be called. But this time, once you say delete p, automatically the destructor is going to be called. Let's check the output, how it is called. Base constructor called, derived constructor called, but instead of going for derived constructor, it calls base destructor. So that means it is skipping the derived destructor. So during this upcasting, so if you try to upcast any base or derived or any pointers or any object, this kind of problem might arise. This derived classes destructor is not called, it keeps on calling the base classes destructor. So you know the drill, you know what you have to do. If base classes function is keep on calling, you have to make base class destructor as virtual. If you make this base class as virtual, automatically you know what happens. First derived will be called and then it goes for the base. Now check the output. Base class constructor, derived constructor, and derived destructor, and then base destructor. Please understand, when you have a situation like this, when you create a pointer for the base class, and when you do this upcasting, casting this derived class into the base class's properties, when you have anything like this, you have to make sure you use virtual in a base classes destructor. If you're not using virtual, it keeps on going to call the base class derived, not your derived classes derived destructor function. I hope you are clear about all these three functions. Your pure virtual function, this pointer, and virtual destructor. So that's the end of your second unit. We have almost covered 85% or 90% of the second unit. We few more have some topics like composition versus inheritance, and we have this upcasting and downcasting. So I'll send that as a PDF and as well as a program related to that. If at all, if you can't able to understand, I'll try to make one more video to explain those composition and as well as upcasting and downcasting. I hope the PDF might help you to understand those topics. So in the next video, we straight away jump into the third unit and we start a new topic, data structures. Thank you.